So, what is it out? Terminal expression.
Terminal expression. Fourth question.
Hmm. Coordinate geometry, no?
Yeah, coordinate geometry.
Okay. Terminal exercise. Fourth question. Okay. Prove that the points of a right angle triangle vertices. Okay. Okay. Good. Okay. So we have to prove that these are the points of right angle triangle vertices. Yes or no? Yes or no? So
Yes, sir.
for example, if I will draw a line, okay, and if I will write the name A, B, and C. Now, because they are not given in series, so I can take anything. Okay, -2, 1, comma 1, and 5, comma 2. Okay. So now, for the right angle triangle, there is one theorem called as Pythagoras theorem.
Bodleian Pythagoras theorem. Oh.
Yeah, both they are Pythagoras theorem. Okay. So in that it is said that h square is equals to p square plus
B.
b square.
So you thought
Now
this,
it is not.
you thought this
Yeah.
in trigonometry. You thought this in
Yeah, I taught this in trigonometry. Now, in this question, because there is no mention of the points that which one is perpendicular, which one is hypotenuse, because I just randomly took 2 minus 2 here, -2 comma 1, 5 comma 2 here. Okay, it is not mentioned that A is this, B is this, C is this, B is right angle triangle. So you do one thing. You do one thing. Every side. You calculate every side, square it. Okay. So for example, I will calculate this AB side. Okay. So like AB is equals to root of x2 minus x1 means -2 whole square plus um, 1 minus of -2 whole square. Did you understand what I'm doing, Agatha? Because I don't know what is hypotenuse, what is perpendicular, what is base in this question. So I am calculating each side, squaring that, and the sum of two squared sides should be equal to the third side. Then it means that it's a right angle triangle. Did you understand, Jashan, Betya, Miracle? Turn on the camera, please. Did you understand?
Yes,
Okay.
sir.
So first we will calculate the AB side. So it will be -4 square plus then 1 plus 2 become 3. 3 square. So AB will become 16 plus 9. So AB will become root of 25. Then AB will become 5 units. Okay. In the same way, guys, you find it out BC. Agatha, find BC. Ira, find CA. And tell me what's the answer of A, BC, and CA quickly. Okay, Jashwan, here I'm not taking anything as hypotenuse, perpendicular, and base. Jashwan, okay, because it's not mentioned. So I'll just calculate each side. I will square that, and if two squared sides, if it is equal to the third squared side, then it is a right angle triangle. If it is not, in any combination, if it is not, then it won't be a right angle triangle. Did you understand, Edric?
yes, sir.
Okay, quickly find it out. Edric, you have to find BCC, everyone. Don't sit. Find BC and CA.
Okay. Hmm. Okay, wait. I'll do it. AB is this one.
Anybody got BC? Miracle, Pritya, turn on your camera, please.
Yes, sir. I got a BC one.
Okay, what's the answer?
Can I tell or should I put in chat?
No, you tell me.
9, sir. 9 units.
Okay. And find CA also.
Alright. VC is equal to BC is this one. No?
Hmm. -2, -5, 1. Miracle, how you got 9 units?
Oh. Yeah, like I got like 3 square, then 3 square, 3 square. 3 square is 9.
But here, like you took what x1, x2?
9 minus 2 was 9.
Like
Plus
this one x1, x2 or this one x1, x2? X1, y1. Is this x1, y1 or is this x1, y1? Which you took?
Uh, I took like B and A, so like that.
B and
A.
A, B and A. A, B we found now 5 units.
I
And
think it's wrong.
yeah, and BC we got root 50. Okay. And AC will be 2 minus 5 minus 2 minus 2. Miracle, if you're not getting it, please ask me. Any problem?
No, sir. Like I have drawn the triangle wrong, so it's been confused like that.
okay now. Okay, so I got
Okay.
CA as 5 units, okay?
Yes.
Okay, so
Right.
basically now you need to square all of them. AB plus CA,
Yeah.
AB square plus CA square is equal to BC square.
Okay. So now if I will square each and every one, so it become AB square will become 25. Okay. And CA square will also become 25 because 5 square. And BC square will become 50 because root will cut. Okay. So if the sum of two sides, if it is equals to the third side, according to the Pythagoras formula, then it is a right angle triangle. So it is 25 plus 25, it's 50. So it means that it's a right angle triangle. Miracle, did you understand why we squared it? Because it is h
Yeah.
square is equals to p square plus b square. So we find it out each side, we square it,
Mm-hmm.
and we find it out the combination. If the sum of the sum of the squared two sides, if it is equal to the third squared side, then it is called as a right angle triangle according to the Pythagoras formula.
Okay.
Did you understand? Yes or no?
Yeah.
Agatha?
Yeah.
Sir, just one thing.
Uh,
Root
uh,
50, root 50 square. The power 2 and the square root will cancel each other, making 50, right?
yes. Basically, root 50 means 50 has a power of half. This is basically means of root. Okay. And when we are squaring it, so it gonna be look like this. 50 1 by 2 multiplied by 2. This 2 and this 2 will cut, becoming the 50 has the power of 1. It means 50. So 50 root 50 square can be written as 50. Did you understand, guys?
Yes, sir.
Shall I read this now?
Yes, sir.
Any problem, Edric? What problem you faced in this?
I thought see, to prove that, no, I thought prove that is only for trigonometry. It's not for this. I didn't know how to prove that for this one.
Okay. Okay. So we were doing this thing. Okay. Now take out your science copy, everyone, quickly. Yeah, everyone is correct answer. Okay. Now we will learn about what we were doing. Yesterday we were doing some question based on the Coulomb's law. Yes or no? So today we will continue with that only. Just give me a second.
Sir,
Yeah.
I got this multifunctional scale.
What is the use of this multi-purposal scale?
Okay. So this is a scale. Then this is you have one scale here. This side you have one scale. Then this side you have another scale. And this side you have a full protractor. And this side also you have a full protractor. And in the middle you have a tiny scale, 5 centimeters. So you have two
Okay.
protractors and 3 scales basically. And the protractors are 360 degrees, not D. It's O. Not
Okay.
Do you know O protractor? Not D. Do you know O? Full 360 degree protractor?
No.
You only heard of D, only 180 degree protractor.
Yeah, 181. Yeah.
That's because you're 90s kid.
Yeah, not 90s. I am 2000. I born in 2002.
2002, that means you're only 23 years.
Yeah.
And when's your birthday?
My birthday is on 17 March.
17th March.
Okay, I'm not getting the question. We
Yeah.
can skip that. Okay.
Coulomb's law, basically.
Okay, no need. If it is not there, okay. So now we will understand a new topic called as electrostatic potential. Electrostatic potential. Okay. So now we will understand this topic called as electrostatic potential. Okay. Now everyone please pay attention. Please pay attention. Okay. So electrostatic potential says us that, for example, considered an uncharged body like glass rod, which is given a certain charge. Body acquires that charge. Now, if you want to add more same nature charge, the charge will experience repulsion due to the already existing charge. Therefore, some external work should be done to overcome this charge. So it is called as K Q by R. Okay, now everyone please pay attention. So for example, there is one body which is positively charged. Okay, positively charged means this body lost the electrons. Okay, now I bring this another charge. I want another charge. Okay, so that they can meet. So for doing that, I need this charge to come near to this. Like this distance, it will come. Then after this, if I will bring this charge body here, then automatically it will go to this. If I will come, I will make him to stand here, then automatically it will come to this. Why? Because this is plus charge, this is also plus charge, they will repel. And when they will repel, they will go like they will go far away from each other. Yes or no? Yes or no?
Yes, sir, yes.
So it means that to make this positively charged body, which is small q, and this is big Q, to make this charge near to this big Q, I need to do some work. I need to do some work. Okay. So the work which I will do, it will convert it into potential energy. Okay. So work done by me will convert into potential energy. Now everyone please pay attention. What do you mean by potential energy? Means I will do an external work to bring the charge here. This is my work. Okay. And when I will release my hand, the charge will automatically will go. So the work which I do to bring that charge to near to this big Q charge, that I have energy, that possess energy. That's why it is moving. Did you understand what I'm trying to say? Edric, don't write. First listen, beta. Okay. I'm saying that, for example, we have two magnets. Okay. Strongly magnets. And this is South Pole and this is South Pole. So this is the normal range. Okay. This is the normal range. This is normal range. There is no force of attraction, repulsion between them. Okay. Now I have to do some work. Okay. To bring this South Pole near to this South Pole. Okay. So I have to do some work and I'm doing it. I'm doing it. I'm doing it. And I make them near to each other like this. Did you understand? This is my work. I did this work.
But you can also make them
Okay.
touch each other. You can also make them touch
Yeah, I can also make them touch each other. Okay, because I did this hard work. Okay. So when they are near to each other, now when I will release my hand, okay, that this South Pole, okay, this will automatically will go away from each other. It means that this South Pole has some energy, no? That's why it is moving. Energy. What do you mean by energy? Like energy helps us to do work. So this South Pole is moving. Automatically it will moving. Nobody is doing anything, but automatically it will moving. So it means that this South Pole has some energy. And how this energy came into the South Pole? The work which I did. The work which I did to bring this to near to this South Pole, that work converted this South Pole into the potential energy. Did you understand? And when I release it, that potential energy converted into the kinetic energy.
So
Did you
potential,
understand?
so potential energy is the energy obtained after a work is done.
Yeah, obtain a work is done against the rules, against the situation, we can say. Like here the repulsion. Repulsion. If I'm doing the work against the repulsion. If I will do the work and if I will bring the South Pole more far away, then there's nothing will be done. Okay. No attraction, no repulsion. But if I'm doing against something, like for example, I am like for example, this is my mobile phone. Okay. You guys can also do it. You can take your mobile phone and you can bring it to the roof. Okay. And you can drop it. Okay, because there is no use of mobile phone. Okay, so like the mobile phone will automatically will smash. Okay, because we are doing work against the gravity. It is going to this some distance. Okay, I am doing some work against the gravity, and then I drop. Okay, then your mummy like that. So what am I trying to say? That the potential energy, what I am doing against the gravity, become a potential energy. In the same way, the charge, the small q charge, which I am bringing near to this big Q charge, I am doing the work against it, and that is converted into the potential energy. And that potential energy which I did, it is denoted by U, capital U. Capital U means potential energy. Potential energy. Or we can, like in electricity chapter, we can say that electrostatic potential, because we are playing with charges. So that's why it is called as electrostatic potential. Okay, electrostatic potential. That is represented by K, capital Q, small q by R. Okay, where U is electrostatic potential, K is same constant, which is 9 into 10 to the power, or it is 9, no? Yeah, 9 into 10 to the power
Plus 9.
minus 9.
Plus 9 or minus 9?
Plus 9, plus 9, plus 9, plus 9. Plus 9
Newton
Newton meter square,
Coulomb inverse square.
Coulomb inverse square. The Q is the charge body.
Okay.
Small q is charge body that is bring from infinite. From infinite. Okay. And R is the distance between them.
Radius.
Distance between them. Okay. So this is basically the R.
Wait, sir.
Did you understand, guys? Yes or no? No. Yes, I'd ask me.
Yes, sir.
You like this.
This is like I got it.
And this is how it can be how I got it.
I was just shaking my
Okay. Yes, Agatha, ask me.
So potential energy is the energy done by the work which is against the nature of the object.
Yeah, against the situation, against the, like for example, we will learn this chapter work and energy with this class also. Like like it is potential energy, and in that we are, if we are raising the object from some height. Okay, one of my old student, he didn't get it till now because he is not opening his mind. I was arguing with him, but he's not able to understand. But you guys will understand it. Okay, he might be listening. So if I'm bringing this height, okay, uh, to this some extent, then I'm doing work against the gravity. Okay, and if I'm doing against the gravity, it has some potential energy. That's why it will break. Okay, yeah, we will understand more deeply in that. But first, write it down this quickly.
Okay, so basically, no, the energy done by a body is the total work that the body can do.
Total work means
I mean, okay. So energy possessed by a body is equal to total work that the body can do. Energy has the same unit as work. That is the joule.
yeah, correct.
Oh.
Done.
Wait, almost. Done, sir.
Okay. I'm erasing this. Okay, 1 minute. Now, this concept is basically work in everything. Okay. Now, everyone, please pay attention. Now, for example, the charge is moving. The charge is moving. And if charge is moved, for example, I did the work against the gravity, and because against not gravity, against this plus q charge, and because of that, the charge moved. Now, this, if it is continuously do, like if continuously the small q charge will move, then what will happen?
Sir, your voice is breaking.
Hello, can you hear me?
Your voice was breaking.
Okay. Hello, hello. Mic test, mic test. Now it is okay.
Yes, sir.
Okay. So what was I'm saying? I was saying that I did the work against this big Q charge, this small Q charge. I did the work against this, and I bring here. Okay, I bring here, and because of the repulsion, the charge will automatically will move. And if I will make the circuit so that this charge will automatically will move and come through the battery again, and then again it will continuously moving like that, then the electric current will flow. Because I told in the beginning also, electricity means flow of electrons or the flow of charge. If the charge will flow, the electricity will be there. Like we understand about static electricity. I am positively charged body because of the woolen clothes, and one of my brother is in negatively charged because of doormat. So when I touch him, the electrons will move from his body to my body, and when the electrons are moving, electricity is generated. Electricity generated, we go both get shock. Did you understand? Yes or no? So this is how the electricity works. Right now, the charge is moving. When the charge is moving, electricity will flow. So basically, this is called as potential. Another word called as potential. Potential stands for, which is denoted by capital V. It stands for work done, which is denoted as W, upon the small q charge. Okay, small q charge. I am taking small q charge. Why? Because the small q charge I am bringing from infinity to a distance. Okay, did you understand? Yes or no?
Okay. So
Okay, that is
potential difference. Not potential difference.
no, no. Potential difference is another thing. I will let you understand what is potential difference.
Sir,
Potential
low
is
please
the
Q.
work done. Q, small q means the charge. The small q charge which is moving. The small q charge is which is moving, which I am doing the work. I'm not doing any work on big q charge. I'm doing the work is from in a small q charge to bring that small q charge from infinity to a distance, to a very near distance r. Did you understand, everyone? Please try to understand, because in the battery, and we will understand it. First write it down. First write it down. Done? Shall I use this?
Yes, sir.
Okay. Okay, I'm erasing this. Okay. So now we will understand the main concept. The main concept is, for example, electric potential. I told you the work done to bring the charge into the bring a charge from Q from a distance of infinity. I will write it down. I will write it down. Okay. So don't write. Okay. Potential, which is V, means to bring a charge from, no, to do a work, means to do a work so that charge small q can come to a distance small r can come to a distance small r. Yeah. Okay. Okay. So this is what is the potential difference. Okay. Okay. So if I will take V, okay. So V stands for W by Q. So if I will do more work, then more potential will be there. If more potential will be there, okay, if more work is there, okay, you can see that W and V both are in numerator. It means that if I will do more work against the capital Q charge, then it will have more potential. And if it has more potential, then the small q charge which I bring near to the big Q charge, it will go more distance against it. Did you understand? Yes or no? Okay, I will make you understand one more time. Like this is plus Q charge, and this is small q charge. Okay, so if I will do a lot of work, so a lot of work means a lot of potential will be generated. A lot of potential will be generated. And if lot of potential will be generated, then the potential energy will be more. And because of electrostatic potential will be more, the charge will go more distance far away from the big Q charge. Okay. So now what I'm trying to say, for example, we have 2 points. This is VA and this is VB. Okay. Did you understand? Now, for example, VB has 5V. Now, what is V? V is the unit of potential. Okay, potential unit is V, and V stands for volt. Okay, so for example, 5 volt is VB and 10 volt is VA. Okay, so obviously, which have more potential? VA. Yes. And if it has more potential, then it will release more charge. And if it is release more charge, then the charge will move charge will move from VA to VB. Okay. Okay. Now, if I will calculate the total total potential of the circuit, which can be calculated by potential difference, which is delta V is equals to VA minus VB. VA minus VB. Okay. Okay, I'm repeating again. Everyone please pay attention. This is important, okay? So we have, I will explain this again. VA and VB, we have 2 potential points. VA has 10 volt, VB has 5 volt. Which have more? VA. VA has more, so more work is there. Okay, VA is more, then it has more work. Can you listen to me?
Yes, sir.
Okay. Now it means that the charge will flow from VA to VB. And if charge will flow from VA to VB, if I will calculate this potential difference of the circuit, it will be VA minus VB means 10 minus 5, which will be 5 volt. Okay. Did you understand? Yes or no?
Okay.
Now because charge is moving, let me complete please. Because charge is moving, after some time it will become 9 volt. and it will become 6 volt after some time. Now the potential difference will become how much? 3 volt. Okay. After some time, this will become 8 volt and this will become 7 volt. Then what will be the potential difference? 1 volt. After some time, it will become 7.5 volt and it will become 7.5 volt. Now, what is the potential difference? 0 volt. Okay. Now, because it is 0 volt, now the cell will be considered as dead.
The battery.
Battery. So in our clock, we have cell. And we know that cell in fresh new cell, it is working. It is helping clock to move. But after some time, the cell become dead. How? Because both the terminal, plus terminal and the negative terminal, both terminal have same potential, like 7.5, 7.5. Now, because there is no difference, the charge will not move. Okay, the charge will not move. And if charge will not move, the cell will considered as a dead. Now we have rechargeable batteries. Okay, in that we plug that, we put that rechargeable battery into that what we say, into that cell holder, and we plug into the electricity. So that electricity converting that battery and making that potential difference again, like 10V and 5V, so that the charge can move again. Did you understand?
Sir.
Hmm?
So,
Yes, sir.
so one charge is there in VA and one charge is in VB. Okay, so VA is 10 volts and VB there are 5 volts. And then slowly it will move from 10 to 5, it will become 9 to 6, then 8 to 7, then 7.5 to 7.5. When there's no difference between the potential, the battery will be considered dead and the charge cannot move.
Yes, because same potential difference is there.
There's no
If-
potential difference. Same, no. 7.5 and 7.5. There's no difference. Only if there's a difference, it will move.
Yeah, if there is a tug of war between Bethia and Ira, then Bethia will simply pull Ira because Bethia has more power, more potential difference, more potential. Okay, and if there is a tug of war between Agatha and Miracle, then the rope will not move because both have same power. Did you understand?
Yes,
So,
sir.
so this is how it works. Yeah, you can write. You can write now.
So there is a same force, balanced force, then it won't move. But there's an unbalanced force, it will move.
Yeah,
Same thing in here also.
yeah. So remember this formula. This formula is very important. Okay.
V is equal to W by Q.
Mm.
Okay. And W is equal to VQ.
VQ. Yes, Agatha. Any doubt? Please ask me, beta.
I got disconnected. Not disconnected. I mean, I got some internet problems. I wasn't really able to listen. So, what is with the 10 volt, 9 volt, 8 volt, 6 volt, and those?
Well, you write it down also, and I will explain it to you also. Okay. You do both those. Okay. Now, for example, VA is 10 volt and VB is 5 volt. So, what will happen? That because of the potential difference is there, the charge will move because it has more power. Okay. Now, after some time, because the charge is continuously moving, the power will decrease. It becomes 9 volt. And if charge is going towards VB, then it will increase. It becomes 6 volt. Okay. And then after some time, it will become 8 volts. It will become 7 volt because he is losing the charges and it is going towards the VB. In the same way, after some time, it becomes 7.5 and it will become 7.5. Now, because though both have same volt, the charge will not move. The charge will not travel from one place to another place. Okay. In this case, the cell will be considered as a dead. So we have wall clock, we have clock. So in clock, we put cell. Okay. the cell helps the clock to move. Minute hand, everything will move, working. But after 5 months or 4 months, the cell will become dead. How? Because the potential difference between both the terminals becomes zero. Now, because both the terminals become zero, the charge is not moving. Okay, so this is how the cell electricity battery work.
Okay. So total potential of a current is the potential difference between V and VB, right?
V and VB. So if you are bringing that clock cell or clock cell into your house, you will check that it is written as 9V, 9 volt, which means that the difference between the positive terminal of a cell and the negative terminal of a cell, it is 9 volt. Basically, 9 volt is delta V, which is the difference of the two terminals. Okay, did you
Okay.
understand?
Wait.
Yeah, right.
Sir.
Okay,
Yeah.
so
Yes, write it down quickly. Write down.
I am writing the word time. Because the charge is moving from V8 to VB, so the potential no, it from V8 will reduce and VB it will increase with time. That's why I'm writing time.
Mm-hmm. Justin, did you understand, beta? Miracle?
The answer.
Okay. Let everyone write.
Okay, voltage is only called potential difference. Voltage, potential difference. The potential difference is called voltage. Okay.
Mm. So you are asking or you are saying that it will be voltage? It will be voltage. What?
Okay. So potential difference is voltage. Okay. Don't confuse potential difference with voltage. Potential difference means voltage.
Okay.
Most people use the term voltage only. Nobody
Oh,
uses potential difference. Just use the term voltage.
okay. Shall I use this?
Sir.
Everyone done? Shall I use this or not?
Yes, sir. Erase it, please.
Okay. Now put a heading of quantization of charges. Quantization of charges. Quantization of the charges. Okay, everyone, please pay attention. Okay. Okay, for example, I have this donut. Okay. Bear with me with drawing, please. Okay.
You have
I
gold
have the
medal in drawing. You have gold medal in drawing. Remember that.
yeah. Thank you. So this is donut. Okay. So what it look like? It look like hard donut. Okay. This is donut. Now the
It
donut.
looks like a vada pav. Vada.
What? So what you like? You
Okay.
make,
So,
machinery.
so vada, no, it's called ulunda vada. Ulunda vada.
Yeah,
Okay.
there are two types of vada, ulundu vada and medu vada.
Parapu vada.
So,
I call it
Yes.
yeah,
yeah.
yeah.
I didn't did big breakfast and I'm very hungry right now. So please don't talk about this word and all. Okay. So yeah. So what was I saying? That we have this body. Okay. Now, if I will remove, two electrons, what type of body it will become?
A positively charged body.
Okay. Okay. So this is basically called as quantization of charges to remove or to make them gain electrons so that the normal neutral body become charged body. And that charge is basically dependent on Ne. Q is equals to Ne. Okay. This Q stands for charge body. How it become charged? When N, which is number of electrons, are removed or gained, and E, which is charge on electron. The charge of
1.6 into 10 to the power minus 19.
yeah. So, for example, if two electrons are removed, then what is the charge on this body? It is positively charged body. But what is the value for that? For finding the value, we have to multiply this 2 into the charge of an electron. So it will become 3.2 into 10 to the power minus 19 coulomb. The charge on the body will become 3.2 into 10 to the power minus 19 coulomb. If one electron is removed, then only 1.6 into 10 to the power minus 19 coulomb charge will be there. Did you understand what I'm trying to say, Agatha? Hmm? If 4 electrons are removed, then we have to multiply this 1.6 with 4. It will become 9.6, I believe. Yeah,
Wait.
9.
If you multiply with 4, it will become 6.4.
Yeah, 6.4. 6.4 into 10 to the power minus 19 coulomb. So the charge on electron is fixed. Number of electron, how much it is removed or how much it is gained, and Q is the charge on the body. Anybody has any doubt? Please ask me.
Sir, what does Q quantization? So we are actually calculating the number of electrons that should be removed or that should be gained to make the body a charge.
Yeah, and which depends of how many number of electrons removed and the charge of a electron, which is fixed.
Okay.
Mamme,
Sir, does all body have a certain amount of charge, everything around us?
how?
Does everything around us, like a bottle, a pen, and all, have a certain amount of charge?
If it is charged, then every time if you will touch them, you will get a shock. Say, you will do like this. So it is all neutral. Okay, if it is charged, then every time you will touch a floor, ouch, 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 and you will walk like this, like a Tom and Jerry. Tom is moving like this, not like this. You will try to
Like
move,
Tom
but
moves on one leg. He moves on one leg. He has 4 legs because he's a cat.
sometimes it gets charged. Like as I told you, in our side we have to wear a lot of woolen clothes, and because woolen clothes, when we walk, okay, so it rubs with our body, and there is a transfer of electrons between woolen clothes and between body. Now, whenever I will touch a door handle or another person, so we will both will jump. Okay, so because we get shocked. Now days are coming. These are the days of Elijah.
These
Okay.
are the days of Elijah.
Okay. So, so these days are coming. So for that, I am inventing one invention I will bring one copper plate and I will put into the earth so that all the electrons which I get access from the woolen clothes, it will directly go to the earth. It is called as earthing. So I will do this invention. So every time, when I will walk, there is a tail of copper tail which is going to the earth. Okay. Okay. So you guys done? Shall I read this?
Yes, done, sir.
Okay. But Ira is saying you are out. I'm not out, Ira. What is this? This is out, no?
Yes, that is out. And that day you said you took 2 wickets. No, today how many?
Today I didn't play.
Yesterday?
Tomorrow maybe. It's just an occasional match. We don't have regular matches because regular matches I can't afford because it's a healthy thing.
Like
My body.
because Team India plays like once in 3 days or something.
Yeah, like that.
Done, sir.
Done, sir.
But I'm raising this. Okay, now we will do one question based on this. Okay, I will do this question. Okay, who will read this? Jashan will read this. Jashan, please read this.
Find
Yes,
the
Jashan.
charge of the body if 2 into 10 to the power 4 electrons are transferred.
Yeah, if 2 into 10 to the power 4 electrons are transferred, find the charge on the body. So we have the formula. Everyone please pay attention. Q is equals to NE. Okay, Q is the charge on the body. What is the number of electron? Number of electron is 2 into 10 to the power 4. And how many? What is the charge on the electron? The charge on the electron is 1.6 into 10 to the power minus 19 coulomb. So I will just put the values into it. So n value is 2 into 10 to the power 4, and E is 1.6 into 10 to the power minus 19 coulomb. Okay, so I will solve this. 2 into 1.6 becomes 3.2 into 10 to the power minus 19 into 10 to the power 4. Now, this 10 and 10, the base is same, power is different. We have to add this. Okay, this is the law of exponents. That will become 3.2 into 10 to the power minus 19 plus 4. Why I did this? Because base is same and power is different. Did you understand? So Q will become 3.2 into 10 to the power minus 20 coulomb. So this will be the charge on the body.
Minus 15. Minus 15. Minus.
Betya message me 13. That's why I wrote. Okay. So it's 15. Minus 15.
We need law of exponents for this, right?
Yeah. Yes. Did you understand, everyone? Any doubt, ask me.
Yes, sir.
Kunjam doubt.
Konjam means little.
Yeah, little doubt.
Sir knows Tamil and Malayalam a lot.
Yeah, I know every language. I mean, I know Ludhiana also.
Sir knows Japanese also. Konnichiwa, sayonara.
Konnichiwa, sayonara, genki desu ka? Genki desu ka? Or I know Hindi also. I know English also. I know Marwari also, where I'm living. I know UP also, UP language also. So I'm linguistic person,
And
Bhojpuri, sir?
Yeah, I know everything.
You know Mandarin?
Hello. I'm not
Mandarin.
able to. I'm not able to hear you. Hello. Am I getting your voice? Hello, Agatha. You saying something? Yeah.
Well,
What?
I was just saying you also know Chinese language.
Yeah, I know. Hey, Hans, you should come here. Like that.
Ha. Ni hao.
Okay. I'm editing this. Now I will give you one question to do it.
1 second.
Give impossible question.
Okay, I'll give to you. That's the question. In my tab it's 8% battery. And we have 20 more minutes for the class. Let's see who will win.
Sir, I think you will. I think the class will win because only 7 minutes left. I mean, not 7. 10.
20 minutes left. Okay, amazing this. Okay, you guys do this. You know, you need hard question, the hardest question to do it. The hardest question. Yes, Jishnu. जी गलत है जी
That's actually the easiest question.
So the question is if the charge of the body is plus IC, no, it's plus 1C, right?
Yeah.
Okay. So calculate the number of electrons are remaining,
are removed.
are removed.
Means how much is removed. Side one. नहीं रख नहीं shut up.
Got the answer, sir.
सही है पर थोड़ा पतला होना चाहिए
Uh, 10 power plus 19.
करेक्ट या Ira, it's not correct, Ira.
Sir, can you do this sum?
Yeah, I will do this. I will do it. Agatha is not correct. Ira is not correct. Adric is not correct.
It is correct, sir.
No, it is not. Check one more time.
So number of electrons is 1, right?
No.
No.
If number of electron is 1, then why will the question will say number calculate the number of electron? Okay. So now I will do this. Nobody did the correct one. Very easy question. Please listen. Now we have this. If we have Q is equals to 1 coulomb, okay. If we have Q is equals to 1 coulomb, we have E, which is 1.6 into 10 to the power minus 19 coulomb. We have to find the value of N. So we have the formula Q is equals to Ne. Now Q is equals to 1, and we have to find and E is 1.6 into 10 to the power minus 19 coulomb. Now it in the form of multiply, it will go and it will divide. So it becomes 1 upon 1.6 into 10 to the power minus 19 is equals to N. What I did, I sent this multiply to this side, it become divide. Did you understand? So it will become 10. It will become 10 upon 16, and the minus 19 power will go in the numerator, it become plus 19. Did you understand? Is equals to N. Now I have to divide this 10 divided by 16, and the answer will be 0.625 into 10 to the power 19. And if I will bring this point to this side, it becomes like here the 19 becomes 18. It becomes 6.25 into 10 to the power 18 electrons. So it means that if from a body, if I will remove this much electron, how much? 6.25 into 10 to the power 18 electron means 6.22500000000 till 18. If I will remove this much electrons, then the body will possess 1 coulomb charge. Did you understand, Edric?
But sir, I also put plus 90.
I haven't saying the way maybe not correct. You did with this way only.
I didn't do this way. I just put 1.6 and 10 power plus 19 because
Did you understand, guys?
So one step is 10 by 16 times 1019, right?
10 by 16 into 10 by 19. Yeah.
And we only do the operation with 10 and 16.
And 10 divided by 16. When you will divide 10 divided by 16, you will get answer is 0.625.
0.62.
Yes, just run. Miracle, Betya, what did you understand? Ask me.
I understood, sir.
Okay.
I also got it, sir. When you just, I immediately realized you have to do another method. I realized this, but too late.
पहले तो खत्म हो जाए. Okay. So now I'll give you one more question. Shall I raise this? Edric, you wrote this thing? Edric,
sir.
you wrote this thing? Yes or no?
Sir.
Okay. Now write one question. If 10 joule work is done, okay, I will write it down. If अरे this is the question. Better read this, please.
If 10 joule work is done to move 4 coulomb charge, then calculate potential.
Hmm. So how we will do this? We know that work is given, which is 10 joule. Okay. We know that charge is given, which is 4 coulomb. Okay. Which is, I mean, charge, which is denoted by Q. So Q is given as 4C. Now we have to find the potential, which is formalized W by Q. Okay. Now V is equals to the work done is 10 joule upon the Q is 4. If I will solve this, it becomes 2.5 volt. So this is the potential.
Okay, so
With 4 coulomb,
Hmm?
with Q is equal to, okay, I see, 4 coulomb.
4 coulomb.
4 coulomb. Short form of 4 coulomb is 4C.
Yeah. C is the unit of charge. So coulomb is C.
wait.
Yes, guys. Now I will give you one more question.
Done, sir.
Everyone done?
Yes, sir.
Okay. Now I will erase this. Hmm. Now I'll write this question. Okay. Miracle, can you read this?
If 6.25 into 10 the power of 20 electrons charged body has a potential of 5 volt, calculate the work done.
Yeah. Guys, I will do this.
Okay, sir. So we need to find the charge, the Q in
Hmm.
coulombs. So first we use Q is equal to any formula, and then we should use
Good. So you guys have to find the Q. Q means charge. What is the charge? Okay. The charge formula is Q is equals to Ne. We have the number of electrons. We know the E value, which is 1.6 into the power minus 19. Solve it. And then put the value of that charge into the V is equals to W by Q formula.
like W is equal to VQ.
Did you understand, guys? Mayakni, what did you understand? Ask me, beta. Yes.
No, sir. Understood, sir. Like, what formula did you use in this question?
The two formula that we learned, Q is equals to Ne. First, we find the charge because its number of electron is there. So, with the help of number of electrons, we have to find the charge of the body. Then I found the charge of the body, which is 100 coulomb. Then we have the electrostatic potential, which is W by Q. Now V, which is 5, W is the work, and Q is the coulomb, which I got 100 coulomb. So I put the value and then I find the work, which is 100 joule, 500 joule.
Okay.
Did you understand, guys? Yes or no?
Done, sir. Got the answer. I also got same thing. 500 joule.
Correct. Very good. Yes, sir. What
I
doubt,
got
beta?
No, I got it, sir. What's happening?
Okay.
How much charge is your right hand?
Mine.
Just check.
Four.
4%.
4%. So
It lasts another 20 minutes.
2 minutes.
Okay. So any problem? Any doubt? Doubt illa.
Doubt illaye.
So it's a bad situation, bad news for you guys that there is no homework.
Good news.
Good news, sir. It's not a bad news for us.
Sir, actually never give science homework. You only give math homework.
But
Oh,
sir,
you want?
no. I want math homework. See, I want okay. So in math, no, which question we didn't do? Wait. I'll check which questions we didn't do in math. So we didn't do the terminal exercise first question, second. I mean, first question, third and fifth. First question, third and fifth.
So, if you didn't did it, then better you have to do it. Okay, you're saying no, yeah. So I believe that you will do that question also.
Okay. So I think for terminal exercise we need.
Edric, you were getting a whole
What?
weekend without homework.
So basically, I think in terminal exercise, first question, third and fifth we didn't do. First question.
Okay, so put that homework remark and write it down. That question number 1, 3, and 5, which we didn't do, you have to do as a homework. Thank you, Ed. Okay, so I hope you enjoyed the class. Till then, bye. Have a nice day. Signing off to the Basha.